All right, homework 6, solving quadratics by completing the square. So we had a little bit of an intro by doing just solving by using the square root property. So this one, some things like number 1 and number 2, you can solve by factoring the side on the left. So the left-hand side is already written out as one of those perfect square trinomials. And remember that pattern is if you cut this in half and square it, you get this number. And so you've got that pattern here, you've got that pattern here. So what we can do with these is we can factor down the left-hand side and solve it using the square root property. So my left-hand side, remember we're looking for what multiplies to 4 and adds to 4, and that would be a positive 2. So it's positive 2 and positive 2. Since it's a repeat factor, you just write it as x plus 2 squared, and then you still have the 49 on both sides. So now this is very similar to what we were doing when we were solving by taking square roots. The only reason is, or I'm sorry, the only difference is instead of being just an x squared, this is an x plus 2 squared, but the solving is still the exact same. So you want to make sure the squared is by itself, which it is. There's nothing added or multiplied to this term right here. So the next step would be to take the square root of both sides, just like we did a couple days ago. So just like x squared, if you take the square root, you just get an x. If I have x plus 2 squared, when you take the square root, you just get x plus 2. When you're solving by square rooting, remember to always include a plus or minus. And this one happens to come out evenly. So the square root of the square root of 49 is 7. And then you would simplify this up by subtracting this 2 that you have from the left-hand side. All right, so this, you get the x by itself by subtracting 2. And then you have plus or minus 7. So this one you are going to get 2 different values. All right, so we've got x equals, the first one is negative 2 plus 7, and then the second one is negative 2 minus 7. All right, so when you add these 2 values together, you get 5. When you add these 2 values together, you get negative 9. So make sure that we are writing our values in numerical order in set notation. So that would be your answer for number 1. Our next section, when we actually go through the process of completing the square, we've got a 6-step process. These problems can get a little bit complicated, so I want to make sure that I'm doing one that's not super straightforward, so I've chosen number 6. All right, so I'm going to walk you guys through the step-by-step process. So number 1, rewrite it as ax squared plus bx on the left, and then just the c on the right. So this one, the first step is actually already done for you. This is how you want your problem to look at the end of step 1. So like this one, you'd have to make sure the 16 ends up on the left. This one, you have to make sure the constant ends up on the right. Same thing with this one. 6, step 1 is already good, ready to go. Step 2, divide both sides by a. Okay, so whatever value is here, you're going to divide everything on both sides by that value. So I'm going to divide out this 4, both sides. So now this, the 4's will reduce down. So this is x squared plus 6x equals, and then this is something that doesn't reduce down. It's always best to just leave things like that, like as fractions, rather than doing them as a decimal. All right, so that's what it looks like so far. Third step, complete the square by taking half of b and squaring it. And then you add that value to both sides. Okay, so we're going to do little bit of work with this. Okay, so you take that middle number, cut it in half, and then you take half of that value and you square it. Okay, so the number that we get from this completing the square step is 9. You're going to take that 9 and add it to both sides of the equation. Okay, so that looks like this. Okay, so I'm going to add a 9 to the left. I'm also going to add a 9 to the rights. All right, that was step 3. Step 4, factor the perfect square trinomial. Okay, so by doing what I just did, I turned the left-hand side into a perfect square trinomial. All right, so the value that multiplies to 9 and adds to 6 would be 3 and 3. So since it's a repeat, I just write it as x plus 3 squared. So that's step 4. Step 5, we need to simplify up that right-hand side first. Right-hand side, one thing you want to do, especially when you're dealing with fractions, is make sure that they have a common denominator so that you can combine them. So for this, I'm going to multiply by 4 over 4, and this becomes 36 over 4. So combine those up since they have the same denominator. Negative 35 fourths plus 36 fourths, we end up with just a positive 1/4. All right, so that wraps up step 4. Step 5, take the square root of both sides. So this actually, where we are right here, is basically where we were with a problem like this right here. All right, so take the square root of both sides like that. And the step-by-step says this will create two cases because the square root has a positive and a negative value. Okay, so we have x plus 3 equals both positive and negative. And then when I take the square root of a fraction like this, remember you take the square root of the numerator and of the denominator. So this comes out to be a 1/2. All right, so we've got our two cases. We can subtract that 3. So we have a negative 3 once we subtract it from both sides, plus or minus 1/2. Okay, so we're going to write our two different cases like this. We have negative 3 plus 1/2. And we also have negative 3 minus 1/2. All right, so this is going to give us our two different values. I'm going to sneak it in down here in our set notation. So this one's going to be smaller. Negative 3 minus 1/2 would be negative 3.5. Negative 3 plus 1/2 would be negative 2.5. It's like you're at negative 3 and then you go up a little bit. So negative 3.5, negative 2.5 would be your two values for number 6.